Hello everyone. In today's lecture, we go to the topics in Unit 1. This unit contains only two topics. First one is how to find roots of an equation. How to find the roots of an equation. And second topic is how to solve system of linear equations using numerical methods. Let us see the first topic. Numerical methods for root finding problem. So in this lecture we will discuss numerical methods for the root finding problem. Specifically, the root finding problem is for a given function f of x, we need to find x equals to some zeta such that f of zeta equals to 0. Then the number zeta is called root of the equation f of x equal to 0 or 0 of the function f of x. Here, the function f of x may be algebraic function or transcendental functions. Before going to solve this, the equation f of x equal to 0, we need to recall some definitions. The important definitions are, the first one is algebraic function. Algebraic function is nothing but a polynomial expression form. So, if f of x is a polynomial function, then it is called algebraic function. For example, f of x can be in the form of a0 plus a1x plus a2x squared plus and so on plus an x power n, where a0, a1, a2 and so on an are some constants with an is non-zero. If an equals to 1, then the polynomial is called monic polynomial. Second definition is transcendental function. If f of x contains algebraic, trigonometric, hyperbolic, exponential, etc., there are some other functions too, then the function f of x is said to be transcendental function. For example, we can take the equation sin x plus x cos x equal to 0. Sin x is a trigonometric term and x is algebraic term, cos x is trigonometric. So our f of x is together with polynomial and trigonometric functions. So the equation is said to be transcendental equation. You can see the second example. This is x e power x minus 2 equal to 0. Here x is algebraic term and e power x is an exponential function and 2 is algebraic term. Hence, this is an example of transcendental equation. Next definition, root of an equation. A number a is said to be the root of the equation f of x equal to 0 if and only if f of a equal to 0. For example, we can take f of x equal to x square minus 3x plus 2. It is a second degree function, second degree polynomial. If we take x is equals to 1, then f of 1 is equals to 0. Thus, x equal to 1 is a root of f of x equal to 0. Similarly, we can check with x is equals to 2. That will be giving f of 2 is equals to 0. Hence, x equal to 2 is also another root of f of x equal to 0. So, we have seen the definition of root of an equation. So, here in iterative methods, in numerical methods, we need to use its graphical meaning. Graphically, the root of equation f of x equal to 0 is the point where the graph or curve of y is equals to f of x cuts x-axis. That means we should remember that if graph of y equal to f of x cuts x-axis, then only there will be a root of the equation. If the graph doesn't cut x-axis, then there is no root of the equation f of x equal to 0. So we are going to use this graphical meaning to find the root of the equation by iteration methods. So if the graph cuts x-axis, then we may see that some of f of x values are positive and some of f of x values are negative. Hence, if we're going to use this definition, the graphical meaning of root of the equation, we should remember one more important theorem, that is by intermediate value theorem. This theorem states that if f of x is continuous function in some interval closed interval a comma b such that f of a and f of b are of opposite signs inside the interval, then it has a root in that interval. That is, opposite signs in the sense, if f of a greater than 0, then f of b must be less than 0, or else if f of a is less than 0, then f of b must be greater than 0. This theorem is very useful to identify where the root exactly located. If this is identified once, then we can use our numerical methods to find the root of the given equation. For example, let f of x is equals to x cube minus 4x plus 1 equal to 0 is the given equation. And it is very clear that its degree is 3. It is a third degree polynomial equation. Moreover, it is said to be algebraic equation. And we all know that it will have 3 roots. All the 3 roots cannot be obtained at one step by using numerical methods. There is a computational methods. To each root of this equation, we need to identify its location where the root is exactly lying. For example, if we want to find one root of this equation, for which let us see how to identify the interval. Among the three, any one root can be determined. Let us see its location, for which randomly we are choosing x values. Initially, we are taking x equal to 0, so that f of 0 is obtained as 1, which is positive. So, you must choose x value randomly so that the function value will have opposite sign, in the sense negative sign. So later we took x is equals to 1. Then f of 1 is obtained as minus 2, which is less than 0. So for x equal to 0, function value is positive. For x equal to 1, then the function value is negative. Since f of 0, f of 1 are of opposite signs, then the root lies in the interval 0, 1. That is what our intermediate value theorem. F of a, f of b are of opposite signs. Then the root of the equation lies in that interval, nothing but it is closed interval a, b. So in this example, we have identified that there is one root of the equation x cube minus 4x plus 1 equal to 0 that lies in the interval 0, 1. Similarly, to find another two roots, we need to choose x values randomly, and then we need to pick up the values like f of x, f of a, f of b are of opposite signs. In this chapter, we use two iterative methods to find the root of the equation f of x equal to 0. They are regular falsy method and Newton-Raphson method. Let us discuss the first method in next lecture. Thank you.